Hello. This video focuses on the various media that connect network devices. We will identify the cables needed to make successful LAN connections and explain variables that need to be taken into consideration when planning a network. Before using an IP phone or accessing instant messaging, we must connect end devices and intermediary devices via cabled or wireless connections to form a functioning network. When selecting and connecting these devices, there are a number of factors that need to be considered. These factors include, but are not limited to, cost, types of interfaces, speed, expandability, and manageability. When planning the installation of LAN cabling, there are 4 physical areas you need to consider. Work areas are the locations devoted to end devices such as PCs and IP telephones. Each work area has a minimum of 2 jacks that can be used to connect an individual device to a network. The telecommunications room is the room where connections to intermediary devices such as switches and routers are found. These devices provide the transitions between the backbone cabling and the horizontal cabling. Horizontal cabling refers to the cables connecting telecommunications rooms with work areas. Backbone cabling refers to cabling used to connect telecommunications rooms or to connect the facility to an ISP. Backbones typically require high bandwidth media such as fiber optic cabling to assure users have access to outside resources. When connecting devices on a network, there are 3 main classifications of media: copper, fiber optic, and wireless. Each type of media has advantages and disadvantages. Some of the factors you should consider are maximum cable length, cost, and bandwidth. When estimating cable lengths, networkers use floor plans or diagrams. Each cable type has a maximum cable length after which signal loss takes place. For this reason, you need to make sure you fully understand the limitations of the selected media. The cost associated with LAN cabling also varies. In a perfect world, the budget would allow fiber optic cabling to every device in the LAN because it provides greater bandwidth than copper. However, the material and installation costs are significantly higher for fiber than for copper. So, as a network engineer, you need to balance the performance needs with the cost of the equipment and cabling to achieve the best cost-performance ratio possible. A third characteristic that varies among media types is bandwidth capability. As you see in the table, the bandwidth for each type of cable can vary significantly. When considering how much bandwidth is needed to connect 2 devices, you need to determine how much traffic will pass between those devices. Let's look at the cables that connect devices. UTP, or unshielded twisted pair, is the most universally used copper cable in a LAN. UTP cables have 2 male ends called RJ45 connectors, one on each end of the cable. When viewed from the top, the RJ45s have pins numbered from 1 through 8. It is important to know this orientation so you can identify the different types of UTP cables. In an Ethernet LAN, devices are connected by either straight-through or crossover cables. For us to distinguish the difference between these 2 types of connections, we can examine the order of color-coded wires. For example, this graphic is an illustration of a straight-through cable. You can tell this is a straight-through cable because the order of color of pins 1 through 8 is identical on each end of the cable. T568A and T568B are the 2 standards for straight-through cables. Usually, one standard is chosen and used for all cabling in a network. Conversely, to identify a crossover cable, we see that the order of wires on each connection is not a mirror image of its opposite. Some of the wires in a crossover cable are, as the name implies, crossed over. This means that the transmit pins on one end of the cable connect to the receive pins on the other end. Almost every LAN utilizes both straight-through and crossover cable connections, but how do we know when to use each one? As a rule, when connecting different types of devices, you use a straight-through cable, and when connecting the same type of device, we use crossover cables. For example, you use a straight-through cable to connect different types of devices, such as a connection between a router and a switch, between a switch and a server, between a hub and a computer. This is because in devices that provide LAN connectivity, such as switches and routers, the transmit and receive pins cross over internally to provide connectivity to the end device, such as a computer. In this graphic, there is a connection between 2 routers and a connection between a hub and a switch. Since both of these connections are between the same or similar devices, they are connected using a crossover cable. A switch to a switch, router to router, computer to a computer, and a computer to a router call for crossover cables. This video covered some of the factors to consider when choosing the media for different areas of the network. As you continue your studies, you will need to increase your knowledge of cable types and practice knowing when to use and knowing the differences between straight-through and crossover cables.